everyone, my name is Rishab Kattimani and I live in Dallas, Texas in the US. So today I'm going to be showing you how to make a face recognition program that can identify people's faces and it can also show their names in the live video feed itself. We'll also talk about enhancements to make this program even more awesome. I'm really looking forward to doing this live coding session with you guys and see you there.
Next speaker, and please in this case I would like you to welcome here Rishab Kattimani. Rishab is really, honestly, I'll tell you because probably somebody who's watching us for the first time ever and is thinking what this teenager is doing here actually. Rishab, tell me how old are you right now?
So I'm 12 years old.
And you're already coding?
Yeah.
Using Python programming language?
Yep.
I'll tell you honestly, maybe I'm mistaken. Maybe there is like someone younger than you, but honestly, you're so far the youngest programmer I know. I don't know, is there some developer who's younger than you? So honestly, I'm really excited to meet you. I'm really excited that you're doing this. For example, and moreover, for the time being, you're not working for the company, obviously, because you're only 12, but still, you already know how to talk about the face recognition using Python. That will be the topic of Rishab. Rishab, just a few words. So you're now 12. When did you start?
So I recently started just once quarantine started, I think last summer. My dad started teaching me technology like HTML, and he's teaching Python. And I was really excited to learn AI and artificial intelligence. So my dad suggested I do face detection. And then once I did that, then I wanted to do face recognition. And here we are.
Honestly, I'm really excited to listen to your topics. So please share the screen and the floor is yours. I am sure that a lot of our audience, a lot of our also enthusiasts, active Python developers today I really want to know more of your tips. So please share them with the audience.
All right. Okay, let me present this. All right. Hello, everyone. My name is Rishab, and today I'm going to introduce you guys to face recognition using Python to code. So first, let's see what we'll do in today's session. So first, I'll introduce myself and a bit about me. Then we can get a simple introduction to what face recognition is and how it works. So there are actually many types of face recognition programs to do many different things. So today we'll see what our program will do. After that, we'll go over some real-world applications to use face recognition. Then we'll just get straight into the demo to code the face recognition program. And to do that, we'll do the face recognition program in 4 simple steps, and we'll talk about that later. And then if we have time, we might look at some other face recognition programs to do other stuff. So before we get into today's topic, let me introduce myself. My name is Rishab Kattimani, and I'm a 12-year-old who likes to learn all kinds of technologies and programs in multiple different languages like Python and Swift. I also run a YouTube channel called Rishab Teaches Tech, where I teach all of my programming and technology finding through these kind of videos. So recently, I was interviewed by a company called Fauna for my technology YouTube channel, and we discussed my technology learning journey. And I've also done another live session earlier today on the junior track to talk about my Python learning journey and web automation. So that was just an introduction to me. So let's get into today's topic, which is face recognition. Face recognition is a simple subset of AI that compares one input image of a face to another, and it uses biometrics and other algorithms to see if they're the same. So the way it can actually recognize those faces is because just like fingerprints, everyone has their own unique facial structure, and this algorithm will remember those facial structures. So like I said before, there are many different types of face recognition programs, but in today's program, we'll take a live video from the webcam and show that back onto the screen, frame by frame. We'll also recognize certain people, and if it recognizes them, then it'll tag their name under the face in the live video feed. If it didn't recognize them, then it'll put a tag under their face saying unknown person, and you'll get to see this later today. So if we look at the live video feed from the webcam, it's basically just a series of frames, as shown in this picture. And these frames, when played in a sequence at a particular speed, will make up the motion in that video. So in our case, we'll extract each frame from the live video from the webcam, and for each frame, our code will do face recognition and tag the face with the name that it recognizes. Or if it doesn't recognize the person, then it'll just tag them as unknown. So let's talk about some use cases of face recognition. So the first use case is to verify valid users. This can be used in multiple different environments. Like, for example, let's say you're in a work environment and you only want to let in work members or crewmates or something like that. Then you can use face recognition to recognize if it's the right person that you're looking for and then only open the door. Face recognition to verify valid users is also used in iPhones. It's used like Face ID to unlock the phone or complete a transaction or something like that. You can also use face recognition to control access to private areas. These areas can include laboratories or data stores, and you can use face recognitions only to let certain people in, connecting back to the first use case. And finally, you can also use face recognition in a school environment to mark attendance, so you can recognize each student if they're present or absent, like that. So let's talk about all the different steps we have to take to do today's live demo. So to do the face recognition program we're going to do today, there's 4 steps. The first step is just basically getting the live video feed frame by frame and then showing that back to us. The second step is to do face detection. And face detection is basically drawing a box around all the faces. So it'll find all the faces that it sees on the webcam and then draws a box around it and then shows it back to us. The third step is to write unknown under those boxes. So again, it'll do face detection and see all the faces and draw a box around it. But this time under that box, it'll write some text saying unknown. And then the last step is face recognition, where instead of writing unknown under all the faces, it'll recognize some certain people and then write their names. Or if it doesn't recognize the person, then it'll just say unknown. And without further ado, let's get on into the demo, where we'll do the first step, which is getting the live video feed and showing it back to us. And let's go to Atom. Atom is a coding editor that I use to do Python in. So the first thing we have to do is import all our libraries. So right now I'm going to import a library called CV2, and CV2 stands for OpenCV. OpenCV is a library that's used for it helps us do the computer vision algorithms and face recognition algorithms, and it also lets us draw and write text on images and videos. In this case, we're going to use this to draw the boxes around the faces in the live video feed. So I'm going to create a variable called video capture. And this variable will just let us capture the video frame by frame. So I'm going to use a function from CV2 called video capture. Video capture. And then let's say we have multiple sources of the video. We're going to type in 0 so that we get only the first source. Then we have to loop through each frame. Like I said before, we have to loop through each frame so that we can show it back to us frame by frame. So how I can loop through it is by using a while loop. So while true, oh, I spelled that wrong, okay. While true, we're going to make a variable to process each frame, and then it'll take that processed frame and then show it back to us. And we're going to add the showing function inside of the while loop so that it shows each frame by frame. So I'll make the variable called ret and then frame so that we can use it multiple times. And then video underscore capture is the variable that we created here for the live webcam. .read. Read is a function from CV2 that'll just process each frame. And let's call this ret, not ref. And then last thing we have to do is just show it to us, show it back to us. So cv2.imShow. imShow is a function that just shows each frame back to us. And in this case, we only have to write it once since it's already in the while loop, looping through each frame of the live video feed. And what we want to show is a video, that's the file format. And then we want to show it frame by frame. So we're going to use the variable we defined here, which is the processed frame. And right now, if we ran the program, then it would work, but then it wouldn't ever stop. It wouldn't ever gracefully stop taking the video and stop showing us the video. So just so that we can do it gracefully, let's make it so that if we hit a certain button, then it'll just stop recording the video and stop showing us the video. So how we can do that is with an if command. So I'm going to say if cv2.waitKey. WaitKey is a function that waits for us to press a certain key for a certain amount of milliseconds. So I'm going to say 1 millisecond. So for every frame, it'll wait 1 millisecond for us to press a certain key. And to tell it what key, we have to say and 0xff equals, and then we're going to use the ORD function. And then now we can just type Q. Let's say if we press Q, then it should stop. Let's say if we press Q, then it should stop recording and showing us the video. But you can make it any other button. So it'll wait for us to press this Q button for 1 millisecond every frame. And if it does, then, oh, sorry, this is improper syntax. We need two equal signs. So if we do press the Q button, then it should break out of the loop, and then outside of the loop, we can say video capture, which is our variable we created here to capture the video, dot release, so that it just releases the handle to the webcam. And then we want to destroy all the windows that it created. So whenever we run this program, it'll create a new window, and then it'll show us the live video feed. So I'm going to say cv2.destroy all windows, so that it just destroys all the windows that it created. So now we can save this and run it. So I'll go to terminal, and before we can run this, we have to actually do some setup. So I would recommend you to make a virtual environment for face recognition. And a virtual environment basically just keeps all of your modules and libraries in check, and it keeps all of them organized. So how we can make a virtual environment, it's different for different operating systems, but for Mac, it's Python 3 -m, venv, and then whatever you want to call it. In this case, I'm just going to call my virtual environment work. And then you would press enter, and then it would create a new folder inside of the local folder. And to activate the virtual environment, you have to say source, and then the name of the virtual environment. In this case, it's called work/bin/activate. And then the way you know it worked, for me, it didn't do anything because I already activated mine. But the way you can know it worked is because at the beginning of all of this folder structure and stuff, it'll say work in parentheses. And then we can install the libraries. So in this case, right now, we only have to install OpenCV because that's what we're using here. So I'll install, so pip install OpenCV. So it's not written as CV2 in terminal. In this case, it's OpenCV-Python because we're using the Python version of OpenCV. And then it'll say requirement already satisfied because I already downloaded it, installed it, sorry. So let's clear this. And now we can run the program. So Python 3, and then whatever the program name is. In this case, it's called facerec.py. So facerec.py. Then, okay, there we go. So it's taking the live video feed frame by frame, and it's showing it back to us. And as you can see, the frame rates are pretty high, but as we use more functions, then it'll get a little bit slower. And as you can see, if I X out of it manually, then it doesn't work. I have to press Q, and then it stops. And that's the first part of the, that's the first step in the face recognition code. The second step is to do face detection. And in face detection, what we're going to do is find all the faces in the live webcam and then mark them by putting a box around it. So for face detection and face recognition, we're going to need to use a module called face_recognition. So I'll import that into my code. Face_recognition. Oh, okay, there we go. And face_recognition is not only just used for face recognition, it's also used for face detection. So there's a little problem. CV2 or OpenCV, it uses a color format called BGR, but face recognition uses a color format called RGB. So how we can convert that is by making a variable called RGB frame. So frame, this frame variable, this is in BGR color format, but RGB frame would be in RGB color format. So for the value, we can say frame, which is the BGR color format, and then in square brackets, colon, comma, colon, comma, colon, -1. And what that does is it just flips around from BGR to RGB. And now we can use this every time we need to use RGB or a face recognition function. So to find all the faces and the face encodings in the frame of the video, we have to make a variable. So first, let's find the faces. I'm going to make a variable called face locations. And we're going to use a function from face recognition library called face locations. And then we want to get the face locations of RGB frame. And the reason why we're not using regular frame is because this is a face recognition function, and face recognition uses RGB color format. So we're going to use RGB frame. Then we want to get the face encodings or the face structure so that we can use it later. So I'll say face encodings. And that'll be equal to face recognition. It's another function called face encodings. Face encodings of RGB frame, because we're getting it from RGB frame, and also face locations, because we need to get the locations of the faces. So now we're getting all the faces that we found and the encodings of those faces, but now we want to actually draw a box around each face. So how we can draw a box around each face is by looping through them. So I'll make a for loop. And just so that I can use these coordinates later on, I'm going to call it top, right, bottom, left. And we need to get it from face encoding, which is each face that we find. And then we want to also get it from face locations and face encodings, because that's the locations of the face that it finds in the live webcam and the face encodings that it finds in the live webcam. And we want to get all of this in a zipped format, so we can just use the zip function, which already comes with Python. Face locations and face encodings. Zip. And then we need a colon because it's a for loop. And then for every face that it finds, now this is just looping through every face that it finds in the live video feed. So for every face, we want to draw a rectangle or a box around the face. So I can use a function from CV2. So like I said, OpenCV is also used for drawing and writing text on images and video. So now we're going to draw a rectangle. So I'm going to use the rectangle function. And we want to draw it in frame. And we're not saying RGB frame because this is CV2, which uses BGR color format. And let's say left and top, and then right and bottom, just so that it goes all the way around the face. Then right, bottom. And then now we have to provide the color and the transparency or the weight. So the color is in BGR color format. So let's say we want it to be blue. Then we can say 225, so 225 of blue, and then 0 of red, or 0 of green and 0 of red. And then finally the weight, we'll just say 2 in parentheses. So that's basically the transparency, or if it's filled or not. And then again, it does the same thing. It shows it back to us. And then if we press the Q button, then it breaks out of the while loop, and then it destroys all the windows. So that's the second part of the demo. What it'll do is it'll find all the faces, and then it'll loop through each face that it finds in the live webcam, and then it'll draw a rectangle around each face. So let's test this out. Okay, so let's use Python 3 faceRec.py. And oh, actually, I forgot something. Since we're using the face underscore recognition, we're also going to have to pip install it. So pip install face underscore recognition. And it's going to say requirement already satisfied because I already installed it, but it is a very needed thing to install. So now we can just run our program, Python 3 facerec.py, and it's taking the live video. There we go. Okay, so as you can see, it found the face and it's drawing a blue rectangle around it. And as you can see, if I move it around, then it also follows. And if I cover up my face, then it goes away because it doesn't see the face anymore. And if we hit Q, then it just breaks. All right, so step 3. Step 3 is to simply draw, it's simply to write text under that box saying unknown. So how we can do that is by first, okay, so as you can see here, it's going to draw a box around her face, and then it should have this little rectangle of the same color, and then it'll write the name, or in this case, it'll just write unknown. So how we can do that, first we have to draw the little rectangle under the box. So I'm going to do another cv2.rectangle, and then we're going to put it in frame. And then this time, instead of just saying left, top, right, bottom, we're going to say left, and then bottom, minus 35. So this is going to be 35 pixels below the bottom. That's why we have minus 35. Just so that it's a little bit below the bottom. And then right bottom, same thing. Right bottom. And then again, we're going to provide the colors. In this case, I'll just keep the colors the same. So 225, 0, 0, so that it's blue. And then, this time instead of saying 2, let's say cv2.filled. cv2.filled is a function from OpenCV that just makes the color, or in this case, the rectangle filled up. So cv2.filled. And then that'll just fill up the rectangle. And the last thing we need to do is write some text. So like I said, OpenCV can also write text in images and videos. So cv2.putText, that's the function we're going to use. cv2.putText in frame. And then this time, we also have to provide what the text will be. So let's say we'll say unknown for everyone that it finds. Then it'll be left plus 6, just so that it'll be a little bit, to the right of the left of the face, if that makes any sense. So like as you can see, it's not just stuck to the left, it's a little bit far away, and it's also a little bit far away from the top also. So left plus 6 and bottom minus 6. So that'll be 6 pixels to the right of the left and then 6 pixels to the bottom of the bottom, if that makes sense. And then the font we can use is CV2 or OpenCV already has some pre-made fonts, so I'm just going to use that. cv2.font_Hershey duplex. But it also has many other fonts. And then the font size is 1.0. And then the color, let's say we want it to be white. Then that would be 225, 225, and 225. So it would be the same amount of all of the colors, just that it's white. And then again, 1 for the transparency. And then we'll save this. And now it does the same thing, face detection, except under that, it draws another rectangle, and then it puts the text inside of that rectangle saying unknown person. Or in this case, it's just unknown. So let's go back to terminal so that we can run this program. Python 3 facerec.py. And there we go. Okay, so it says unknown so first it draws the blue rectangle, and then it says unknown inside of that. And if I cover up my face again, then it doesn't detect the face, and then it just doesn't show that. And if I hit Q, then it breaks that again. It stops recording. And the last step is to do face recognition. So it'll recognize a certain face. In this case, let's just make it so that it recognizes my face only. And then it'll, instead of saying unknown, then it'll say my name. So first thing we have to do is tell the program what faces it has to recognize. Like I said, I'm just going to make it recognize just my face. And I actually have a sample image or a reference image that I want to give to the program so that it can recognize my face based on this image. So I'm going to make a variable to load this image file. I'll call this Rishab image. And for the value, we'll use a function from face recognition. Oh, what happened? Face recognition called load image file. Load image file. And then now we would have the image file. In this case, it's called rishab.jpg, so I'll just mention that there. Rishab.jpg. Then we'll save this. And now we want to, like I said, we have to make it recognize the face structure so that it can actually recognize the face. So I'm going to make a variable called Rishab face encoding to do that. Encoding. And then we're going to use the face encodings function again. So let me just copy this. So we're going to use face recognition dot face encodings so that it can get the face encodings of the loaded image file, which in this case is stored in Rishab image variable. And then after that, now it'll know to recognize my face, but let's say there were more than one face. Then we have to store all of the faces that it recognized in an array, and then also provide the names. So first one is known face encodings. Known face encodings. So this will store all of the face structures that it already has in an array. So in this case, it only has Rishab face encoding because I'm only recognizing one person. But if you had more than one, then you could just add them there in the array. And also, we wanted to write Rishab here. So to do that, we have to provide all the known face names. So known face names, also in an array, even though there's only one value. And then this will say Rishab. And yeah, so now it knows who to recognize, and we've already stored all of the known face encodings and known face names in two arrays. Now we can actually compare the known face names now we can actually compare the known face encodings to whoever we find on the live webcam to recognize if they are Rishab or not. So to do that, while we're looping through each face, for every face that it finds, we want it to compare the person on the live webcam to known face encodings, which is all the face encodings that we have. So how I can do that is by using a variable called matches. So matches. And then we're gonna use another. Okay. Now we can use another function from face recognition called it's called, I think, compare faces. Compare faces. And now to recognize the person, we want to compare the faces of whoever's on the live webcam to known face encodings, because that's all the people that we want to recognize. And now we want to compare the faces of known face encodings to face encoding. And face encoding is the variable of whoever is on the live webcam right now. And let's initialize a variable called name, and we'll initialize it as unknown. So name will be just the default value of, so right here, you know how it says the text it adds right here? As default, it'll be unknown if it doesn't recognize the person. And if it does recognize the person, then we have to make it change to whoever we have in known face names, because that's all the names that we have. So how we can do that is, I want to get the closest match of there might be multiple people in known face encodings. In this case, there's only one person, which is me, but there might be multiple people, and I want to get the closest match of who in known face encodings is the closest match to whoever is on the screen. Or if it doesn't match anyone, then that's also okay, and then we'll just keep it as unknown in that case. So I'm going to say face distances, which is a variable we'll create, to get the closest match. And then we'll use a function called face distance. Face distance. And then we want to get the face distance between known face encodings and face encoding, basically getting the closest match. So known face encoding and face encoding. So again, just to recap. So again, oh, what happened? So again, just to recap, known face encodings is whoever we want it to recognize, or it could be multiple people. In this case, it's only one person though. And face encoding is whoever's in the live webcam. So I'm going to make another variable called best match index, because this known face names might have multiple values, and we want to see who corresponds to what name. So I'll say best match index, and that'll be equal to, we're going to use a function from a module called NumPy. NumPy is mostly used for numeric operations, so we're going to use it here. Import NumPy, and just so that we don't have to say NumPy every time, we'll say import NumPy as np. And then best match index equals np.argmin, which is a function. And then we want to get the argument of face distances, which is the variable we just created. Now this will get the index of whoever in known face names we want. And just so that I said that we initialize the name variable here to unknown, and if it recognizes someone, then it should change that. So now we can see if it recognized someone and then change that variable if it did. So I can use an if statement for that. So if matches is best match index, and best match index. Matches is the variable we defined here to compare the faces. So if they both agree with each other that the person on the screen corresponds to someone in known face encoding, then that means it recognized someone, and the best match index has the certain someone. So now we would say name equals, so we're changing the value of this name variable to whoever in known face names, which in this case is an array. So we need to find the index of who in known face names. In this case, there's only one value, but there might be more. So the index would be best match index, because that gets the index of the best match, which is why it's called that variable. And the last thing we need to do is, right now, again, it will do all these face recognition, but it won't do anything with that, because for everyone, it'll still say unknown. So let's change that to name variable. And so that means name will either be unknown if it doesn't recognize, and if it does recognize, then it'll have someone in the known face names array, which in this case is only me. And let's just check out this whole code. Oh, sorry, I forgot about something important. So let's say in Rishab.jpg there's multiple people. Then our face recognition program wouldn't know who to recognize. And in this case, we need to tell it who to recognize. Even if there's only one person, the program doesn't know that, and we need to tell it who to recognize. So we're going to tell it to recognize only the first image, the first face that it finds. So we're going to say index of 0 to get the first face that it finds. And yeah, that's a basic, simple face recognition program. So let's go over to terminal so that we can run this. Python 3 facerec.py. And okay, it's saying face distance is not defined. Let's check this out. Okay, so face distances equals face recognition. Oh, okay, whoops, my bad. So we're using it from the face recognition library. So we have to mention that face recognition dot face distances, face distance, because face distance function belongs to this library. So let's save that and then run it again. All right, and there we go. Okay, as you can see, it recognizes my face as Rishab, and it still draws the box. And Dad, can you come here? Okay, so I'm going to bring in my dad so that he also can get recognized as unknown in this case. Okay, so here, it shows his face, and it says unknown. All right, there we go. It worked. And again, if we cover up our faces, then it doesn't recognize me anymore because it doesn't see my face. And if we hit Q, then it breaks. So that was it for face recognition. That was it for the live demo of face recognition. And you can also add some enhancements to make this program even more awesome. So for example, if you want to hook it up to a full-fledged device, then you can hook it up to a Raspberry Pi, which is a single board, really small computer that's shown here. And for a Google, the frame rates, as you can see in this demo, are pretty low. But if you want to improve the frame rates, then you can hook it up to a Google Coral Accelerator, which is already shown here. And I actually have a Google Coral Accelerator. If you can see my camera, it's right here. And that like triples the frame rates, so it makes it much more effective. You can also integrate this with a database so that you can do dynamic face recognition, which I actually made a YouTube video on. And finally, you can hook these up to APIs to do all sorts of things based on your needs. And let me just present that again. Okay. And thank you all very much for attending this session. If you want to connect to me on social media, then the links are here. And we'll have our Q&A session shortly.
Yeah, definitely, Rishab. Thank you so much for your presentation, and thank you. You're already pretty well with managing all the social media for yourself. So really good job. I think that we'll definitely discuss a lot of things with you a bit later. As I mentioned a bit later during our Q&A session, I really want to thank you for your presentation. It's really exciting, and honestly, really exciting that you're doing this already at 12 year old. So see you a bit later. Thank you.
All right.